So I wanted to start with, I'm going to go kind of fast because this is only a 20-minute talk and it's action-packed. I wanted to start with a sort of general presumption, which is that it's frustrating when technology, there's no transparency, when it's not made public. And I'll start with the example of breath analyzers. Back in the mid-2000s, cops would be pulling people over, making them blow in a tube, and using that to make a decision as to whether or not to make an arrest. And people thought, well, what if there are problems with the breath analyzer? Why should we trust it? Was there really probable cause for an arrest here? And indeed, eventually some enterprising people got their hands on the source code for Intoxilyzer and found out that it did have some real problems and might yield some false positive results. And anyone who remembers the 80s will remember the Clipper chip endeavor when the government just said, hey, I know what we'll do. We'll hold on to the one true key for all encryption, and you guys can have your own keys, but we'll be able to just kind of backdoor that. And this is an idea with just a built-in fundamental flaw. Should be pretty obvious to everyone here. But anytime you hear just kind of trust us, we know what we're doing, that's what gets me riled up. And so what I'm going to talk about is a series of tools that were developed for surveilling peer-to-peer networks, and they are not made public, and the government just says, just trust us, we know what we're doing. And because they're not public, I haven't seen them. I don't know anyone who has seen them unless they are a sworn agent, and they won't talk to me about it. And so the inferences that I'm going to show you here are made from just reading dozens and dozens of search warrant affidavits when they describe how the thing works and what it does. And so we can make some deductions about what it actually does, and that's where we're headed. So surveillance is fairly pervasive these days. There's a law that says you probably shouldn't install an untappable phone system. We've got the NSA metadata call collection, or call metadata collection stuff, where we realize that content analysis is fun, but traffic analysis can be just as fun. And surveillance is also pretty secret. We usually don't find out about it until there's a leak and everyone gets in the press and heads roll. And there's more than just surveillance going on. By surveillance I mean just passive collection of information. But we see now some more invasive efforts as well. And there's a series of cases right now, the Playpen series of cases, which some people in the room I'm sure are familiar with, where the government embedded some malware that opened a side channel. People would browse to a website using Tor. The government operated that website for a while and implanted some malware that opened a side channel and would leak the user's public IP address back to the government. So that's not just surveillance. That's actually changing things, and you might need a warrant for that. And some cases are getting tossed for that reason, but by far not all. And we know that the government is collecting exploits. That's not been a secret at all. So one of the questions that we have to ask ourselves is, where is the boundary between just good old-fashioned aggressive investigation of crime and violating people's rights and sort of taking things one step too far? So that's the prologue. Let's get down to it. When I talk about peer-to-peer networks, I mean things like BitTorrent, Gnutella, Ares, or eDonkey, or whatever they call it. These have been around for a long time. The Gnutella variant of the tool that I'm talking about was in use at least as early as 2009. I don't know if anyone really uses Gnutella anymore, but I'm sure the tool still exists. And these are generally, the tools that I'm talking about are generally forks of open source software. So there's been a tool developed, like MicroTorrent or whatever, or Fex, that's one of the ones. And some enterprising software developer says, I'm going to make my own version of this that does some extra stuff. So they make use of aspects of the peer-to-peer protocol that are normally obscured from the user. They're below what the user sees. And they add in some features that would not really be of interest to ordinary users, and we'll talk about what those are. So who develops these? Well, one guy, the tool for the Ares network was developed by this one person, Joseph Versace. He's a Canadian law enforcement programmer and analyst. There was a collaboration between the CS departments at a couple of universities and some police departments that produced Roundup, which is kind of the best known of these tools, and it's based on the Fex Gnutella client, and there's a version of it for BitTorrent as well. So they're developed by, normal folks, academics and so forth, and they make new uses of some existing features. So for Gnutella, when you do a search, when you get a query hit, it comes back and it includes the SHA-1 hash value of the files that the search hits are. So this is a nice, quick, easy way to identify if you happen to have a database of files that you knew nobody should possess. You could just see, do these hash values match? And then you'd instantly have good targets for investigation. And Gnutella also has a feature called swarming, where if I admit that I'm sharing a file, I will also try to tell you about all the other people I know about who are sharing that file, so that you can grab it from multiple peers and it doesn't all have to come from me. And then you can directly browse peers as well, not just do searches, but once you've found someone who is a Gnutella client, you can just go and query them and get a list of what files they have, regardless of whether your search turned up those files or not. So those are, kind of interesting features. If you were an investigator, that's kind of fun. On BitTorrent, we have a couple other things. There are what are called tracker messages, and this tells which peers are interested in which torrents. So if somebody is looking for something, you might be able to detect them on that basis. And when they connect for downloads or when they acquire new segments, clients will send out some announcements of what segments they've got so that they can immediately begin participating in the sharing. Remember, the whole idea of BitTorrent was that bandwidth is asymmetrical. We can download things way faster than we can upload them, generally speaking. And so we want to share large files. What we'll do is everybody shares segments of the files, or you share the whole file, but we'll grab a segment from here and a segment from there and a segment from here. And that means we can download multiple things while we're only uploading, whatever our upstream bandwidth is. And then there's something called peer exchange, which is kind of like the swarming feature for Gnutella. So these are the features that it exploits on BitTorrent. And then we add in some features as well. Known file lists, so a database of known files of interest, so that we can quickly determine when we see search query results whether they are things that we want to be investigating. IP geolocation. Are these doofuses in our jurisdiction? So before we spend a whole lot of time investigating something, can we at least tell if we would have the power of arrest over these people? Single source downloading. This is, we don't want to swear out a warrant and go and rouse someone out of bed and seize their computer, only to find out that they only had the first 3 segments of an 80-segment torrent. We want to know that they have the whole thing, and so that means we have to download the whole file from them. So this is completely antithetical to what BitTorrent is designed to do. We're going to, instead of grabbing things from all over the place, we're going to grab them from just one thing. And it's not really a subversion of the protocol, but it's a use other than what it was designed for. And then fake file sharing also. We'll get throttled if we're not sharing anything. And if we share the right kinds of things, we might attract people into connecting to us. Am I doing something funny with the micers? Okay, I'm okay? All right. So we don't want to actually be distributing contraband, so we're not going to actually do that. But we're going to announce that we have it to share, to see who will connect to us, and also so that we don't get throttled. So it looks like we're sharing and we don't get taken out of the network. Finally, we'll have the ability to tag individual clients that we connect to. And there's going to be more on that later, but that's a pretty interesting thing. Can I identify at some point down the road that this was the client that connected to, that I connected to and downloaded from? That would be an important piece of evidence, and we'll talk a little bit about how that works. So what they're going to do, these tools, is impersonate regular old peers on the network. They're going to engage in activity designed to attract connections, whether they're doing searches or announcing what they've got. They'll do queries of their own to find things of interest. They'll inspect the systems that they connect to look at as much as they can in the shared areas. They'll perform those single source downloads and they log their activity. And this is the game plan, right? The investigators will go, make themselves a good log of what they did and what they found, and they'll use that as the basis for obtaining a warrant. All right, so if you were accused of a crime on the basis of a log file, you might like to know, is that log file a reliable source of information? Does it work? And so people over time, attorneys, have tried to get their hands on these tools because they want to know, how does it work? What does it do? And they are uniformly rebuffed. Nobody's, to my knowledge, ever succeeded in that quest. And there have been times when the court has sided with the defense attorney and said, yeah, law enforcement, cough up this code or give them access to a working instance of it or something, and the case will get dropped. So they'd rather do that than burn their source. And this is a curious thing, because on the one hand they say there's nothing interesting about these tools. They're just simple forks of regular open source software. Anyone could make this. It's not a big secret. And yet they'll go to great lengths to preserve the secrecy. And reason number one that they give is it would divulge our database of, naughty files. And first off, I think the software developers in the room just snickered, because who embeds a database in the software that they're distributing? There should be two separate things so that you can update the database without having to distribute a whole new build of the code. So it's probably not exactly that. I don't think the database is literally part of the software. But the reason that they give is if we do this, everyone who wants to trade illegal materials would just go and flip one bit in them, and then all of our hash values wouldn't be any good anymore. And while that's true, that's a two-way street. It wouldn't be any good for the people who are sharing either, because they would not know if you were out on the internet and everybody, claimed to have different files. If the hash values didn't match, how would you know you were getting segments of the same file? So that reason is a little bit shaky to me. But even if everyone did flip bits in their files, that would be so disruptive to the trade of contraband. Maybe you'd want that result anyway. Okay, the code must remain secret. Reason number two, it would disclose the undercover investigators. And here I think they're speaking kind of metaphorically. The metaphor that they use is, well, if we had someone buried deep undercover in a drug cartel, we would use information that they gave us, and that's okay, there's nothing wrong with that. And we wouldn't identify that person unless and until we absolutely had to. Well, this isn't quite like that, I don't think, but it's interesting. So I can think of two possibilities, and they both revolve around the idea that we don't want one law enforcement agency inadvertently targeting agents of another law enforcement agency, going out on a network and seeing, oh, these guys announced that they're sharing all of this stuff, let's go pick on them. So possibility number one is that nodes know about one another. There's some either central database or a list that's published of who's using this software, and that way you can identify your friend on the network and you don't go and pick on him. This also is probably not part of the software itself, but maybe the software contains the means of obtaining that list or something, and that list really should remain secret. That's a legitimate secret. But I don't think that's it, because from time to time they will give you the log file, and that contains their IP address in it, so that doesn't really make a lot of sense. So the other possibility is there's something distinctive in the way the tool does its initial handshake. So when the two peers connect, they'll exchange some information. Usually it'll have a globally unique ID or something like that it exchanges, and there might be something unique in that handshake that would identify this as a non-traditional peer-to-peer client. And I think that's a pretty likely guess. And I'll talk a little bit more about that, because this is how the tagging feature works. All right, so we have some problems with not being able to look at this software, and one of them is just the reliability of the software. Does it ever erroneously make a report? Well, it's quite common, I can tell you from my own experience consulting with attorneys, it's quite common that investigators, when they go and they seize a computer, they don't find the files that they say they downloaded from that computer. That happens well over half the time. There are two explanations for this possible. One is the files weren't there in the first place and the report is wrong. And the second is they don't usually execute their warrants until months after they did the initial download, so the file's just not there anymore. And that's probably pretty likely. But what we don't know is how many warrants have they obtained and executed that didn't result in an arrest. We don't see those. That's stuff that never makes it across an attorney's desk. And so we don't know. So we don't know if there are false positives. We don't know it's the tool's false positive rate. And that, I think, is a worrisome thing. And are there conditions under which it malfunctions? Well, I'm here to tell you that software has bugs. And I mean, we wouldn't even have this conference if that weren't true. He's shocked. This is the first he's heard of it. I can't imagine why we should think this particular software has less bugs than any other, and it might be useful to know what they are. And there's been no review of this. The government just says, yeah, it works. The next problem is the standard for obtaining a warrant. In order to obtain a warrant, you're supposed to establish probable cause that a crime might be committed. And this isn't technology, by definition, this isn't technology that's in the hands of the public. There's a really interesting case from the turn of this century, Kilo or Kylo, I'm not sure which it is, versus United States, where the feds used a forward-looking infrared radar to visualize what was going on inside of a house. And the Supreme Court said, you needed to get a search warrant for that. You can't just do this. This is stuff that's outside of what the public could have. They can't. It violates their reasonable expectation of privacy. And I think that's the case here too. That nobody thinks that there's a tool out there that does this, and it's not in our hands. We can't examine it. We can't see it. And again, this is where the government trots out this, well, this is just modified open source software. Any user could do the same thing. Well, that's farcical. Maybe any software developer could, but most users are not those. But it sort of raises the supplementary question, how would we know we were doing the same thing if we can't see the tool to begin with? Yeah, maybe we could, right? Maybe we could write any kind of software, but how would we know it works the same way that the government one does? And that brings us also to tagging. Right now when you're using these tools, there are shared areas on your computer, so folders full of things that you're willing to share on the peer-to-peer network, and then there's the rest of your computer, which is supposedly off limits. The way the tagging works is in that initial handshake, the law enforcement software will submit a blob of data that's going to get written to a log file. In Gnutella, that's the clients.met file, the list of clients that the thing is connected. That's not in a shared area of the computer, and it contains now a blob of data that the government wrote, and then later when they come and look through the log, they'll say, yep, this is the one we wrote. It's encrypted with our key. So is that something you should have to get a warrant for? I don't know. That's an unlitigated question right now. Or there's been litigation, but we haven't gotten a sensible result. The next thing is, what are the chances you're going to find a judge who's able to tell whether these statements are reliable, that how IP addresses can be connected to subscriber identity, how peer-to-peer networks work, how a government tool based on open source software works? Judges don't know this. They just get a 20-page warrant affidavit and they say, okay, sign. Because they don't have a choice. It's that or conduct a really serious investigation of their own, and it's not going to happen. Another thing is who's qualified to testify about how these tools work in court. You usually see the investigator who operated the software come and say, this is what I did on thus and such a night, but that person can't really explain. That person is trained in how to use the tool, but doesn't necessarily know the inner functioning, that the developer of the tool would know. So I think testimony ought to require more than just knowledge about which button you click to make the single source download happen. And then, of course, again, software having bugs, it might be exploitable to a really enterprising person. These things we know, there's Java-based stuff, there's .NET-based stuff, there's the clients that the tools are derived from. Any bug that those have, this probably has too. And it may have its own bugs too, of course. And one of the things that we've got here is the exploitation would probably go undetected because of this lack of transparency that we've got, and because it's mostly not used by security professionals. It's mostly used by investigators, and they might just not even notice if their software crashes in a funny way one day. All right, I have, I think, about 1 minute left. Okay, I have one. So I could do like a question if somebody's got one. No? All right, well, thank you very much, and thanks for coming to my talk. See you again soon.